Today's lesson, we'll be learning how to determine the a value from a quadratic relation in factored form. Over here, we have the general equation of factored form. Let's start by finding the x-intercepts. The x-intercepts are right over here, +2 and +4. Next, we want to simplify any double signs, which there are none, so this is what we're left with. Next, we're going to sub any point on your parabola and solve for the a value. Preferably, we'd want to be using a non-x-intercept. So this would be a good point to use. This is 6, 4. That's the x-coordinate, that's the y-coordinate. So back over here, let's just copy in our numbers -2, -4. We're going to now substitute in our point. Okay, so the x value of 6 goes right over here, and our y value is going to go over here. Next, we're going to simplify some of these numbers. So this 4 stays exactly the same. 6 minus 2 becomes 4. 6 minus 4 becomes 2. Next, we want to simplify this because there's actually a hidden multiplication between these numbers, which means that simplifies to 4 times 2, which is 8. Next, we want to solve for a, and we can do that by dividing both sides by 8. These 8's cancel out, and we are left with 4 over 8, which simplifies to just 1 over 2. Now we can write our final equation of this quadratic relation in factored form. It would be y equals 1 over 2, x minus 2, and x minus 4. And that just means that it is opening upwards since the a value is positive. It is a compression, so it's a vertical compression by a factor of a half. The x-intercepts are +2 and +4. Once again, we're going to determine the a value of a quadratic relation, but this time in vertex form. Over here, you're going to see the general equation of vertex form. If you look at the graph, let's find the vertex. The vertex is right over here and has a value of -4 and +2. We're going to take those values and put it into our equation over here. So -4 goes right over there and +2 goes over there. Let's simplify the double signs. That's going to become +4 and this is going to stay +2. Next, we want to substitute any point on a parabola and solve for the a value. It would be preferred if you used not the vertex. So you could either use this point over here or this point over here. Let's just use this point over here. This is -3 and +5, where -3 is the x-coordinate and +5 is the y-coordinate. Let's copy down some of our numbers from above. So the +4 is going to stay the same, and our +2 is going to stay the same. Let's take this point on our parabola and we're going to substitute it in. So -3 is going to go right over here and +5 is going to go right over there. +5 stays exactly the same. Let's simplify what we have in the brackets. So -3 plus 4 becomes +1. +2 on the outside stays exactly the same. Next, we're going to keep 5 exactly the same. We're going to simplify this. 1 to the power of 2 is just 1 times 1, which is 1. The +2 on the outside stays exactly the same. We are going to now take this +2 and bring it to the other side, but when you do that, it becomes the opposite operation. So that now becomes -2. This +1 stays exactly the same. Let's simplify 5 minus 2, which becomes 3. This 1 stays exactly the same. Now, to isolate a, we want to divide both sides. We're going to divide both sides by 1. These 1's are going to cancel out, and let's simplify 3 over 1. 3 over 1 just simplifies to 3. So 3 is the a value. Over here, we're going to state our final equation in vertex form. This would be y equals positive 3, x plus 4 to the power of 2 plus 2. And that just means your parabola is opening upwards because that is a positive a value and it is a vertical stretch by a factor of 3. It also means that your parabola has been translated 4 units to the left and 2 units upwards.